In this video, we're going to take a look at the temperature dependence of entropy of formation. So the standard entropy of formation is the entropy change when 1 mole of substance is formed from its elements in their standard states under standard conditions. So here's an example for water, H2O being formed from hydrogen gas and oxygen gas. So it's being formed from its elements in their standard states. Here's an example from methanol. This would not fulfill the criteria for working out the entropy of formation, the standard entropy of formation, because one of the reactants is a compound rather than element. So we've got carbon monoxide there instead of just elemental carbon and elemental oxygen. Also, just to note, standard entropy of formation to form an element in its standard state is 0. So if we take the example of hydrogen gas, well, that's already in its standard state, so there's no change when we form hydrogen gas from hydrogen gas. That's a bit of a misnomer, but it's just illustrating a point. There's no change there, so we have no entropy change. Now, just a note on standard conditions and states. So IUPAC recommends using a standard pressure equal to 1 bar. Temperature is not strictly part of standard conditions, but it's common for tables to report values at a reference temperature of 298.15 Kelvin. The standard state or reference state is the state in which the elements are stable at the standard pressure and chosen temperature. So for example, graphite is often used for carbon. In terms of the symbol then, we've got this delta S to represent the entropy change, this superscript circle to represent standard conditions. Sometimes that superscript circle is replaced with a superscript plimsoll. We have a subscript T to represent the temperature at which this is relevant, and a subscript F to tell us that this is to do with formation. Okay, here's some example data for different chemical species. We've got the state of those chemical species, and then we've got some values for the standard entropy of formation at 298 Kelvin. So these values are all at 298.15 Kelvin. If I just draw your attention for a moment to bromine, that is a liquid under standard conditions. So if we want the value for bromine gas, it's slightly different. So bromine liquid, standard state, so the entropy of formation is 0. Bromine gas is not the standard value, it's not the standard state, so it's non-zero for its value. Also, just draw your attention to water, H2O liquid, that's the standard state. But if we want it in the gas phase, then the value is slightly different again. So just to draw your attention to the fact that sometimes we may have things that are in a different state to their standard state, and that actually can be quite useful in certain situations when we're performing certain calculations. Okay, now onto the temperature dependence. So we have this equation here where we have the entropy of formation at the temperature of interest, that's T2. We have the entropy of formation at the reference temperature T1 and the heat capacity. And that heat capacity is divided by T and then integrated from T1 to T2 with respect to temperature. Now the equation that we often find given for the heat capacity is actually in the form Cp divided by R equals A plus Bt plus Ct squared plus dt to the minus 2. So if we just modify that equation for the temperature dependence slightly to take into account the fact we have Cp divided by R, we then combine those two equations. So instead of having Cp divided by R, we substitute in A plus Bt plus Ct squared plus dt to the minus 2, and that's divided by T, so we can of course simplify that. We can then go through the steps of the integration, and we end up with the equation shown here at the bottom. So this gives us the temperature dependence for the entropy of formation. We just need to know the values of A, B, C and D for the compound or the element that we're interested in, and we need to know the standard heat of formation of that particular species at the reference temperature. So that's been a video about the temperature dependence of entropy of reaction. I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.